I am Radhakrishna, mathematics teacher. First of all, I am very sorry for the delay in the class due to some technical issue, and today onwards there is a change in the times, evening 6:10 to 7:20 first lecture and 7:30 to 8:40 second lecture. So, this will continue from now. Okay. So, let us start the session. We are going to continue our topic definite integration. Today we are going to discuss a new subtopic, that is reduction formulae or Wallis formulae. First, integral 0 to pi by 2 sine power nx dx or integral 0 to pi by 2 cos power nx dx. If you denote it by in, then the reduction formula is in is equal to n minus 1 by n into in minus 2. Let us see how. Integral 0 to pi by 2 sine power nx dx is in. For integral of sine power nx, standard limits are 0 to pi by 2. If any other limits are there, how to calculate it, we will discuss during the problems. We derived the indefinite integration of sine power nx in indefinite integration. What is the reduction formula in indefinite integration? We have derived minus sine power n minus 1x cos x by n plus n minus 1 by n into in minus 2. This is the formula we have derived in indefinite integration. Now, if you take limits 0 to pi by 2, here in minus 2 also will have limits. In minus 2 means integral 0 to pi by 2 sine power n minus 2x dx. In the first term, if you substitute pi by 2, it will be 0 because of cos x, cos pi by 2 is 0. If you substitute 0, again it is 0 because of sin x, sin 0 is 0. So, this term is completely 0, then we get the formula in is equal to n minus 1 by n into in minus 2. And also, using the property of definite integral, you can replace x by pi by 2 minus x. Then you will get sin pi by 2 minus x becomes cos x. So, integral cos power nx dx between limits 0 and pi by 2 is also given by the same reduction formula. So, we can take in as integral sin power nx dx or integral cos power nx dx. Now, by this formula we can reduce n by 2. Okay. In becomes in minus 2 if you apply this formula. But if you want the complete value of in, you go on reducing n by 2 in every step by applying this formula. First n minus 1 by n into in minus 2. Again apply the same formula for in minus 2. You will get n minus 3 by n minus 2. Same formula, replacing n by n minus 2, n minus 3 by n minus 2 into in minus 4. In this way, again for in minus 4 apply the same formula. Repeatedly applying this formula, this in will be equal to n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4 and so on. Last term will be either I0 or I1. You will reduce the numerator and denominator by 2 in every step. But whenever it becomes a negative, there you have to stop. You cannot write negative number, or if it becomes 0, there you have to stop. Then you should write the final term. If you go on reducing the value of n by 2 in every step, if n is even, finally it reduces to I0. If n is odd, it reduces to I1. Okay. Then finally, if you get I0 or I1, what is I0? I0 is integral 0 to pi by 2 sine power 0x. What is integral 0 to pi by 2 sine power 0x? Sine power 0x is 1, then it is integral 1 dx. Substituting the limits, you will get I naught is equal to pi by 2. Similarly, if you want I1, take n is equal to 1. What is the integral of sin x? Integral sin x dx is equal to minus cos x between limits 0 and pi by 2. Now substituting the limits, you will get 1. So whenever you get I1, you substitute the value as 1. Okay. So we can find the value of integral 0 to pi by 2 sin power nx dx or integral 0 to pi by 2 cos power nx dx with this formula in one step. Now let us solve few problems on this reduction formula. First question, integral 0 to pi by 2 sin power 5x. This is I5. I5 is equal to first n minus 1 by n. What is n? 5. N minus 1 by n is 4 by 5. See, n minus 1 by n into I n minus 2. Now after writing I n minus 1 by n, go on subtracting 2 from numerator, 2 from denominator as far as possible. Then subtracting 2 from numerator, you will get 2 by 3 if you subtract 2 from numerator and 2 from denominator. Again if you subtract 2 from numerator and 2 from denominator, numerator is becoming 0. So you cannot subtract. Okay. As long as it is positive, you continue subtracting 2 from numerator and 2 from denominator. Then since you cannot subtract 2 further, next term will be the last term. What will be the last term? As we discussed, last term will be either I naught or I1. Here n is odd, so it reduces to I1. So you should write I1. What is the value of I1? 1. So it is 4 by 5 into 2 by 3 into 1, you will get 8 by 15. Okay. Next question, integral 0 to pi by 2 cos power 6x dx. You can write it as I6. I6 is equal to n minus 1 by n is 5 by 6. And subtracting 2 from numerator, 2 from denominator, numerator becomes 3, denominator becomes 4. And again you can subtract 2 from numerator and 2 from denominator. You will get 3 minus 2, 1 by 4 minus 2, 2. You cannot subtract 2 further. You are getting a negative number in the numerator. If you subtract 2, 0 in the denominator, so you cannot do. So next term will be the last term. What will be the last term? Is it I naught or I1? Here n is even. So if you go on reducing 6 by 2, finally it becomes 0. If n is odd, it reduces to I1. If n is even, it reduces to I naught. So it is I naught. What is the value of I naught? Pi by 2. So it is 5 by 6 into 3 by 4 into 1 by 2 into pi by 2. Simplify it, 3 2s are 6, then you will get numerator as 5 pi, denominator is 2 into 4 into 4. How much? 32. So this integral is 32. Next question, integral 0 to pi sine power 7x. Here the problem is the limits are not standard limits 0 to pi by 2. In that case, we have to reduce the limits to 0 to pi by 2 by applying properties of definite integral. If the limits are 0 and a, what is the property you can use? Replace x by pi minus x. If you replace x by pi minus x, you know that sin pi minus x is sin x. So function remains same. If the function remains same by replacing x by upper limit minus x, what can you do? What is the corresponding property? You can multiply the integral by 2 and divide the upper limit by 2. So I will write this as 2 integral 0 to pi by 2 sine power 7x dx. Now, since the limits are 0 to pi by 2 standard limits, we can write this as I7, 2 into I7. It is equal to 2 into I7. Okay. Now, write the value of I7. First, n is 7, no? So, n minus 1 by n is 6 by 7. Next, subtracting 2 from numerator, 2 from denominator, 4 by 5. Next is 2 by 3, that is all. You cannot subtract 2 further. What will be the next term? Is it I0 or I1? N is odd. N is odd. So, I1. What is the value of I1? Directly you will write as 1. Then simplify it. 3 2's you can cancel, that is all. So, this is 32 by how much? 35. Okay. So, the value of this integral is 32 by 35. Next question, this time again limits are not 0 to pi by 2. What will you do? What is the property, what property can you apply? When the limits are minus a and plus a, you should look at the function whether it is even or odd. Replacing x by minus x, cos of minus x is cos x, function remains same. So, it is even function. So, what is the property? You can integral minus a to plus a f of x dx can be written as 2 integral 0 to a f of x dx if f of x is even. So, I will write it as 2 integral 0 to 2 pi cos power 7x dx. Now, limits have changed. So, again we can try the property, because our aim is to reduce the limits to 0 to pi by 2. Replace x by 2 pi minus x. What happens? Cos of 2 pi minus x is cos x. So, again we are getting the same function. Replacing x by upper limit minus x, if you get the same function, what will you do? Multiply the integral by 2 and divide the upper limit by 2. Then this 2 becomes 4 integral 0 to pi cos power 7x. Again, since limits have changed, let us try the same property. Replace x by pi minus x. What happens? Cos of pi minus x is minus cos x. So, this time you are getting minus 4 integral 0 to pi cos power 7x, replacing x by pi minus x. According to the property of definite integral, replacing x by upper limit minus x, if we get negative sign, the value of the integral is 0, because we got negative sign. If this is I, this is I, this is I, adding them 2I will be 0, so I will be 0. So, no need to calculate anything, answer is 0. Okay. Next question. Integral 0 to pi by 6 cos power 5 3x. In our formula, we have integral sine power nx and integral cos power nx, limits 0 to pi by 2. Here limits are different and this is not x, this is 3x. So, what we will do is, by using substitution, we will make it cos power nx or cos power nt. What is the substitution? Put 3x is equal to t. If you put 3x is equal to t, you will get 3 dx is equal to dt. Then dx is equal to dx is equal to 1 by 3 dt. Okay. Now, this integral will be I is equal to, what will be the new limits? If x is 0, t is 0. If x is pi by 6, t will be pi by 2. Now, we got the standard limit 0 to pi by 2. And what is the function? Cos power 5 t into dt by 3. So, which is 1 by 3 into I5. We know how to calculate I5. It is 1 by 3 into what is I5? N minus 1 by n is 4 by 5. Subtracting 2 from numerator, 2 from denominator, you will get 2 by 3, that is all. Then next step is the last step. What is the last step? Is it I0 or I1? I1, because n is odd. So, I1 is 1. So, what are you getting? Numerator is 8, denominator is 45. So, answer is 8 by 45. Okay. Or in this question, if you remember, I have given you one formula in different integrals, one shortcut formula. Integral a to b f of kx dx can be written as 1 by k integral ka to kb f of x dx. So, using this formula, directly you remove this x, here k is 3, remove this 3, then you will get into 1 by 3, 1 by k. Ka to kb will be 0 into 3 is 0, this into 3 is pi by 2. Then directly you will get this step 1 by 3 into I5. So, we can calculate the answer very quickly. Next question. Yeah, see, this is looking different, no trigonometric function present in the integrand. So, what to do? By using some substitution, we can convert into a trigonometric function, and we have discussed that whenever the terms of a square plus x square are present in the integrand, the standard substitution is x is equal to a tan theta. Okay. So, I am putting x is equal to a tan theta, and similarly, if the function contains a square minus x square terms, what is the standard substitution we have discussed? X is equal to a sin theta. If it contains x square minus a square, we have to substitute x is equal to a secant theta. Okay. And also we discussed another substitution. For a square plus x square, we can put x is equal to a cos h theta, or for x square minus a square, for a square plus x square, x is equal to a sin h theta, or x is equal to a tan theta. For x square minus a square, I have told you two substitutions, x is equal to a secant theta or x is equal to a cos h theta. Okay. Here we want to convert this into trigonometric function, so that we can try the reduction formulae. That is why I am substituting x is equal to a tan theta. Dx is equal to a secant square theta d theta. Now, let us write the integral as I. I is equal to, first change the limits. If x is 0, what is theta? If a tan theta is 0, theta will be 0. If x is infinity, a tan theta is infinity. If tan theta tends to infinity, then theta tends to pi by 2. We are taking the principal values only. Okay. Then dx is a secant square theta d theta by, what is the denominator now? A square plus a square tan square theta means a square secant square theta. A square plus a square tan square theta is a square secant square theta. A square secant square theta whole power 4 will be a power 4 secant power 8 theta. Now, a by a power 4 is 1 minute. It becomes a square secant square theta whole power 4 means here you will get a power 8. Is it not? Then a by a power 8 is 1 by a power 7 integral 0 to pi by 2. Since 1 by a power 7 is constant, I am writing outside. Now, secant square by secant power 8 means what? 1 by secant power 6 theta. 1 by secant power 6 theta means cos power 6 theta. What is this now? 1 by a power 7 into I6. Okay. 1 by a power 7 into, how to calculate I6? By reduction formula or Walli formula, it becomes 5 by 6 into subtracting 2 from numerator, 2 from denominator, 3 by 4 into again repeating 1 by 2 into, you will get I0. I0 is pi by 2. Then what are you getting? 3 2s are 6, then 5 pi by 32. 32 a power 7. 5 pi by 32 a power 7 is the answer. Okay. So, in this way, sometimes by using a substitution, we can reduce into a reduction formula. Another question, here limits are 0 to pi by 4, but function is product of sine and cos. So, what will you do? First multiply by 2 power 4 and divide by 2 power 4. Then 1 by 2 power 4 means 1 by 16 integral 0 to pi by 4. Why did we multiply by 2 power 4? This becomes 2 sin x cos x whole power 4, that is sin power 4 2x. Is it not? Now, it is similar to one of the previous questions. We can use f of kx formula. K is 2. So, immediately 1 by 16 into 1 by k. 1 by k means 1 by 2 integral ka to kb means we have to multiply the limits by 2. Then 0 into 2 0, pi by 4 into 2 pi by 2. What we will get here? Sin power 4 x dx, f of kx formula. Now, it is 1 by 32 into 16 into 2 32 into I4. What is the value of I4? First n minus 1 by 3 by 4, subtracting 2 from numerator, 2 from denominator into 1 by 2. Next step will be I0. I0 is pi by 2. Then we are getting 3 pi by how much? 2 power 5 into 2 power 4, it will be 512. 2 power 9 is 512. Okay. 3 pi by 512 is the answer. Okay. And one more point you can observe, when the in the reduction formula, when power is even, you are getting something into pi, some rational number into pi, which is completely irrational. When the power is odd, you are not getting pi as a factor, you are getting directly some rational number. So, remember that integral 0 to pi by 2 sin power n x dx is an irrational number if n is even, a rational number when n is odd. Okay. Next, one more reduction formula, formula number 2. If you write integral 0 to pi by 2 sin power mx into cos power nx dx as I m comma n, then we can get a reduction formula in which we can reduce either m or n. I am reducing m here. How? If you take Imn is equal to integral 0 to pi by 2 sine power mx, I will prove it on another page, space is not enough. Imn is equal to integral 0 to pi by 2 sine power mx cos power nx. In this reduction formula, integrate by parts, but for integrating by parts we need first function and second function. I want to reduce m, so I will separate one sin x, integral 0 to pi by 2, you write it as sine power m minus 1x into sin x into cos power nx dx. You can write it like this. Now taking this as first function, this as second function, we can integrate it by parts. Why this is second function? Because this is integrable. You can integrate this because derivative of cos x is sin x. If you separately integrate integral sin x into cos power nx dx, what will you get? If you put cos x is equal to t, sin x dx will be minus dt. Then it becomes integral t power n into minus dt. It will be t power minus t power n plus 1 by n plus 1. What is t? Cos x. So its integral is known. So integrating by parts now, first function into integral of the second function. Integral of the second function is minus, I will put minus here, cos power n plus 1 x by n plus 1. First function into derivative integral of the second function minus integral of derivative of the first function into integral of the second. Derivative of the first function is m minus 1 sine power m minus 2x into derivative of sin x, you have to multiply, that is cos x, okay, into integral of the second function. Integral of the second function is what? Integral of this is minus cos power n plus 1 by n plus 1 dx. Now we have to use the limits. Take brackets here, limits are 0 to pi by 2, and in this integral take limits 0 to pi by 2, right. Now substituting pi by 2, it will be completely 0 because of cos x, cos pi by 2 is 0. Substituting 0, again it is 0 because of sin x. So first term is completely 0. Now what I am getting? Second term only, that is minus into minus is plus, okay. Imn is equal to, take out the constants m minus 1 and n plus 1 into integral 0 to pi by 2 sine power m minus 2 x into cos power, cos x into cos power n plus 1 x is cos power n plus 2 x. But m has reduced, but n has increased, then there is of no use. So, what we do is we will reduce this power also by writing it as cos power nx into cos square x. It is m minus 1 by n plus 1 into integral 0 to pi by 2 sine power m minus 1 x into, you can write this as cos power nx into cos square x. We can write cos square x as 1 minus sine square x. Okay. Now, multiply by this inside, you will get Imn is equal to m minus 1 by n plus 1 into, if you integral of sine power m minus 1 x into cos power n x into 1. What is it? If this is Imn, this will be I m minus 1 comma n. Sorry, it is m minus 2 now. Multiplying by this inside, this into 1 is sine power m minus 2 x into cos power n x, which is I m minus 2 comma n. Minus is there, minus again m minus 1 by n plus 1 into this into sine square x will become sine power mx cos power nx integral 0 to pi by 2. What is it? Imn. This is Imn. Now, taking this Imn this side, what you will get? 1 plus m minus 1 by m plus n plus 1 into Imn is equal to m minus 1 by n plus 1 into I m minus 2 comma n. Here take LCM and simplify. Finally, you will get Imn is equal to, space is not enough, so I am writing the direct step. Imn is equal to m minus 1 by m plus n into Im minus 2 comma n. This is the reduction formula for integral sine power mx into cos power nx. In the same way, if you separate cos x and proceed in the same way, separating cos x, you have to take sine power mx into cos x as second function, cos power n minus 1 as first function, and proceed like this. Then you will get this as m comma n minus 2, n will reduce. This becomes I m comma n minus 2, here you will get n minus 1 by n plus m. Okay. You can reduce either m or n. Now let us see the formula. We have just proved that Imn is equal to m minus 1 by m plus n into Im minus 2 comma n. So by applying this formula, we are able to reduce m, n remains as it is. Now one more thing you can observe is, replacing x by pi by 2 minus x, integral remains same now, property of different integral. Replacing x by pi by 2 minus x, what happens? Sin x becomes cos x, sin pi by 2 minus x is cos x, cos pi by 2 minus x is sin x. Then this becomes sin power cos power mx sin power nx. Then that will be Inm. So in this kind of reduction formula, if you want, you can interchange m and n. Okay. And another point is, you can also calculate the value of the Imn directly in one step. Just like first formula, first you write m minus 1 by m plus n, you are reducing m by 2. Then again applying the same formula, m should be replaced by m minus 2. So this becomes m minus 3 by m plus n minus 2. That means you are subtracting 2 from numerator, 2 from denominator. Again repeatedly do it. So what happens, m will be reduced completely. If m is reduced completely, then if m is even, finally you will get I 0 comma n. If m is odd, you will get I 1 comma n. So what we do is m minus 1 by m plus n you write, subtract 2 from numerator, 2 from denominator, continue it as long as possible. Then finally you should get I 0 comma n or I 1 comma n. If you get I 0 comma n, if m is 0, then this is not there, sine power 0 is 1, then it is the previous reduction formula. So we can write it as I n and use that formula, previous reduction formula. If we get I 1 comma n, suppose m is 1, if m is 1, then sine power 1x into cos power nx, and we have already discussed about this. Derivative of cos x is minus sin x, so if you put cos x is equal to t, you will get sin x dx as minus dt. So it becomes this, where t is cos x, and integral of t power n is t power n plus 1 by n plus 1, t means cos x, so minus of cos x power n plus 1 by n plus 1. Now if you substitute the limits, substitute upper limit pi by 2, it will be 0, minus, substitute the lower limit, you will get minus 1 by n plus 1. So you will get 1 by n plus 1. Okay. So if you get I 1 comma n, you will write 1 by n plus 1. If you get I 0 comma n, you will use previous reduction formula. Now let us see some problems. First question, integral 0 to pi by 2 sine power 6x into cos power 5x. It is I 6 comma 5. Okay. What is the first step? M minus 1 by m plus n. M minus 1 is 5 by m plus n is 11. Subtract 2 from numerator, 2 from denominator, it becomes 3 by 9. Again you can subtract one more time. 3 minus 2, 1, 9 minus 2, 7. That is all, you cannot subtract further. So the next term is the last term. What is the last term? Here m is even. So you will get I 0 comma n. So you will get I 0 comma 5. It is nothing but I 5. So I am using the previous formula. 5 by 11 into 3 by 9 into 1 by 7 into, what is the value of I 5? Previous reduction formula, n minus 1 by n into I n minus 2 formula. N minus 1 by n is 4 by 5, again subtracting 2 from numerator, 2 from denominator, 2 by 3, that is all. What is the next term? 5 is odd, so last term will be I 1, I 1 is 1. Now you calculate the value, 3 cancels, next 5 cancels, that is all. 4 into 2, 8 by 9 into 11 into 9 into 7, that is 99 into 7, that is 3, 693. Okay. So this is the value of the integral. Next question, integral 0 to pi sine power 4x into cos power 6x. Here limits are not standard limits. So as we did in the first formula examples, we have to use the property of definite integral and reduce the limits to 0 to pi by 2. Replace x by pi minus x. Sin pi minus x is sin x, cos pi minus x is minus cos x, but power is 6. So, it remains same. So, replacing pi x by pi minus x, function is remaining same. Then which property? You can integrate, you can multiply the integral by 2 and divide the upper limit by 2. Then it becomes 2 integral 0 to pi by 2 sin power 4x into cos power 6x, right. Now, limits are standard limits. Let us proceed with the formula. 2 into m minus 1 by m plus n, m minus 1 is 3, m plus n is 10. Subtract 2 from numerator, 2 from denominator, you will get 1 by 8 into I 0 comma 6, I 0 comma 6 is I 6. Why I 0 comma 6? Because 4 is even. Now calculate its value. 2 5s 3 by 40 into I 6. 5 by 6, first step, n minus 1 by n, subtracting 2 from numerator, 2 from denominator, 3 by 4, again 1 by 2 into I naught is pi by 2. Okay. Now, you simplify and get the answer. Next question. Again, limits are 0 to pi, but powers are both odd. So, if you substitute, if you replace x by pi minus x, you will get integral 0 to pi sin power pi minus x into cos power 7 pi minus x. What is sin pi minus x? Sin x. Sin x whole power 5 is sin power 5x. Cos pi minus x is minus cos x. Minus cos x whole power 7 is minus cos power 7x. So, we are getting minus sign in the second factor. So, it is equal to minus integral 0 to pi sin power 5x into cos power 7x. When you get minus sign by replacing x by upper limit minus x, what is the value of the integral? 0. Okay. Next question. Integral minus pi to plus pi sin power 4x into cos power 6x dx. Here limits are in the form of minus a and plus a. So, check the function is even or odd. Both the powers are even. So, it is an even function. So, I will write it as 2 integral 0 to pi sin power 4x cos power 6x dx. Now, replacing x by pi minus x, we are getting the same function. So, again by applying the property, you will get 2 into 2 4, divide the upper limit by 2, 4 integral 0 to pi by 2 sin power 4x into cos power 6x, which is I 4 comma 6. You know how to calculate this. You continue. 4 into m minus 1 by m plus n, that is 3 by 10 into 1 by 8 into I 6. 4 2s are 8, 3 by 20 into, write the value of I 6. I 6 is 5 by 6 into 3 by 4 into 1 by 2 into pi by 2. So, 5 4s can be cancelled, 3 2s. So, finally, we will get 3 pi by, how much it is? 2 cube, 2 cube, 2 power 6, 2 power 7. 2 power 7 is 128. Okay. Next question, integral 0 to 1 x cube into 1 minus x whole power 4 dx. We can convert into a reduction formula by using a substitution. If you substitute x is equal to sine square theta, what happens? Dx is equal to 2 sine theta cos theta. And what are the new limits? If x is 0, theta will be 0. Sine square theta is 0 means theta is 0. If x is pi by 2, then what is the value of theta? Sorry, if x is 1, if x is 1, theta will be pi by 2. If sine square theta is 1, theta is pi by 2. Okay. Then the given integral I will be integral 0 to pi by 2 x cube means sine power 6 theta into 1 minus sine square theta is cos square theta. Cos square theta whole power 4 means cos power 8 theta into dx is 2 sine theta cos theta. Right. Then take out to 2 integral 0 to pi by 2, this into this sine power 7 theta into cos power 9 theta, which is in the form of our second reduction formula. So it is 2 into, what is the formula? M minus 1 by m plus n is 6 by 16. 6 by 16 into, subtracting 2, 4 by 14 into 2 by 12. That is all. You cannot subtract 2 further because numerator is becoming 0 if you subtract 2. Then you will get I 1 comma 9 because 7 is odd into I 1 comma 9. What is the value of I 1 comma n? We have discussed 1 by n plus 1. So this I 1 comma 9 is 1 by 10. So here you simplify 2 into 4 into 2 16, 16 cancels, 2 3s are 6, 7, 3 4s. Then you are getting 1 by 28 into, what is that? 1 by 10. So answer is 1 by 280. The value of this integral is 1 by 280. Okay. We can also solve this question in another method. If you remember, we have derived one important result in previous class. What is that result? Integral 0 to 1 x power k into 1 minus x whole power n minus k dx is equal to 1 by n plus 1 into nck. We have derived in the last class only. So you can directly use, remember this and use in this question. Here integral 0 to 1 x cube into 1 minus x whole power 4. This is the given question. Then this is k, this is n minus k. So what is n? N will be 7. So what is the value of this? 1 by n plus 1 means 1 by 8 into 7c 3. Then it is 1 by 8 into 7C3 is 7 into 6 into 5 by 3 factorial. By 3 factorial means 6. So, what are you getting? 1 by 8 into 7 into 5. 8 7s are 40, 40 into 7. We are getting the same answer, 1 by 280. Okay. Next question. Next question is integral 0 to a square minus x square whole cube. As we have discussed, we have to use trigonometric substitution and reduce it to reduction formula. What is the trigonometric substitution for a square minus x square form? X is equal to a sin theta. Put x is equal to a sin theta. Then dx is equal to a cos theta d theta. Given integral is I. What are the limits, new limits? If x is 0, sin theta should be 0, theta will be 0. If x is a is equal to a sin theta means sin theta is 1, then theta will be pi by 2. Integral 0 to pi by 2, a square minus x square means a square minus a square sin square theta whole cube into dx is a cos theta d theta. Now taking a square common here, a square whole cube is a power 6 into a. We will get a power 7 integral 0 to pi by 2. 1 minus sin square theta will be cos square theta. Cos square theta whole cube, cos power 6 theta into cos theta. It will be cos power 7 theta. Now you know how to calculate this. This is I7, a power 7 into I7, you calculate it. Okay, I will proceed to next question. Integral 0 to 2 minus x whole power 3 by 2 dx. Here, what is the suitable substitution to convert into a reduction formula in sine and cos? You think limit should become 0 to pi by 2 and this should become either sine or cos. You can easily get the idea that substitution is x is equal to 2 sin square theta. Put x is equal to 2 sin square theta. Okay. Then dx is equal to 4 sin theta cos theta d theta. And what are the new limits? If x is 0, theta will be 0 because sin square theta will be 0, theta will be 0, principal value. If x is 2, 2 is equal to 2 sin square theta means sin square theta is equal to 1, theta is equal to pi by 2. Then that integral I is equal to integral 0 to pi by 2 2 minus 2 sin square theta whole power 3 by 2 into dx is 4 sin theta cos theta d theta. Okay. Now simplify it. Here you have 2 common. 2 power 3 by 2 means 2 root 2. I will write it outside. 2 root 2 into 4 integral 0 to pi by 2 1 minus sin square theta whole power 3 by 2. 1 minus sin square theta is cos square theta. Cos square theta whole power 3 by 2 means cos cube theta into sin theta cos theta. Now this is 8 root 2 into integral 0 to pi by 2 sin theta into cos power 4 theta. This is what I 1 comma 4, I 1 comma 4. What is the value of I 1 comma n? 1 by n plus 1. So, 8 root 2 into 1 by 5. Answer is 8 root 2 by 5. Okay. Next question. This must be 3. What is the substitution here? Put x is equal to 3 sine square theta. From the previous question you must get the idea. Putting x is equal to 3 sine square theta, you can convert this into the reduction formula of integral 0 to pi by 2 sine power mx into cos power nx. Okay. If x is equal to 3 sine square theta, dx is equal to 6 sine theta cos theta d theta, and limits will be 0 to pi by 2. I already explained in the previous question, so I am writing direct steps. X power 3 by 2 means 3 power 3 by 2 means 3 root 2 into sine square theta power 3 by 2 means sine cube theta, sorry 3 root 3 into root over 3 minus 3 sine square theta means root 3 cos theta. Now dx is 6 sine theta cos theta. Right. Now simplifying it, it is this into this 9, 9 into 6, 54. Integral 0 to pi by 2 sine power 4 theta into cos square theta, which is I 4 comma 2. You know how to calculate it, you finish the calculation. So, time is up with this question. We are going to conclude the session, and we are going to continue in the next lecture and solve some more problems in reduction method. Okay. Thanks for watching. See you in the next class.